Yeah, get excited. All right. We're going to go through a couple of exercises today, but I just want to, although we talked about all the information for 4C, and we've also talked about all the information for 4D, they're two of the exercises we're going to do. I just want to confirm that we've done that and let you see what it is. First things first, because there are heaps of people away. So we record it so they don't miss out, because I care. All they can hear is you guys asking questions now. What's wrong? No. Well, they will hear you if you're all talking. So try and keep the noise to a minimum and then it will be good. So that it sounds better. Of course. All right. We talked about our normal... Right, my turn. Y equals mx plus c. That's a nice way of writing our equations, isn't it? Where m is the gradient and c is the y-intercept. At first, I'm talking about this is 4C. You don't need to take anything down right now. Just watch and make sure that you've seen it, and then it'll all be there, so it's okay. We talked about there are some lines that are different. They don't fit that y equals mx plus c beautifully. One of those is the vertical line. A vertical line going straight up and down, we talked about the fact that it always has the same x coordinate. Any point on that line, that's the line x equals b, this would be the point, if it's going to let me write, b, comma 1. The x-coordinate is b, and then this point would be b, comma 2. This point there would be, yeah, b, comma 3. We've already got onto it. Gee, if I went negative and I went down to negative 1, b, negative 1 on the axis, b, comma 0. We get the idea? The x-coordinate never changes, does it? For a vertical line, the x-coordinate's always the same, so we just write the equation as x equals whatever the number happens to be. E.g., if I wanted to sketch x equals negative 2, I draw my axes, y, x, and I put a vertical line going through where x is negative 2. And it's that easy. I know we'd seen a couple of those. I just wanted to make sure we'd made sure of that. Yeah. In an exam, would I say sketch the line x equals negative 2? Probably. That's an exam-like question. It's a simple, familiar question. I just want you to recognize it. Or I could give you this line and say, tell me the equation of this line. Oh, wow. He's made it really hard. He hasn't put a normal number there. He's put pi as the intercept. Does that make it any harder? No. What's the equation of the line? X equals pi. Vertical line. X equals a number. If it goes through pi, it's x equals pi. Nothing complicated about that. Horizontal lines, y equals c. What's the gradient of a horizontal line? It's a gradient of 0. Yeah, mx, there's no mx part to that line, y equals a number, is there? Because the gradient's 0. Remember my gradient? Rise over run. There is no rise. It doesn't matter which points I choose horizontally. 0 divided by any number is 0. That's why there's no x component in y equals a constant. It's just y equals a number. Nice and easy. I didn't mention what the gradient of the vertical line is. I will do that in a second when we go to the next exercise. But that's all they were doing. Then they, for some reason, make a big deal about these equations which go through the origin, and they just say y equals mx. But it's just y equals mx plus c. Oh, my little stylus doesn't really want to work. They're just the special ones where c equals 0, so we don't bother writing it, and it just looks like y equals mx. All of them work the same way, nothing special. The first two, the vertical and the horizontal line's a little bit special, especially the vertical, because it doesn't have a y, it's got x equals. Everything else just works the same as y equals mx plus c. So those questions, we've already done some questions on that, but when in the homework sheets. But if you want to try a few of those, that'll be fine. I don't think you'll have any trouble with them at all. Vertical lines, x equals a number. Horizontal lines, y equals a number. Problem solved. So that's our first little bit. That was exercise 4C. It doesn't want to. There we go. I will force it to do what I want it to do. I'm going to jump to 4D, which would be the next exercise, Wow, they're talking about gradient. Well, we've already mentioned gradient because I knew you guys remembered it from last year, and we wanted to talk about y equals mx plus c early. All the different ways we describe gradient on the right, on the upper right there, rise over run. Remember the Greek letter delta, the triangle? Greek letter delta, change in y divided by change in x. What's the change between two y coordinates? You do the difference. y2 minus y1. Change in horizontal distance, change in the x coordinates, x2 minus x1. Or vertical change divided by horizontal change. All different ways of saying the same thing. That's my gradient. Positive gradients, uphill from left to right. Positive, we're feeling up, aren't we? So they should be going uphill from left to right. Negative, what's another way for describing when you're feeling a bit negative? A bit down. I'm feeling down. Negative, downhill from left to right. Yes. What's which one? Delta means, delta is this little Greek letter that is hiding there, and my stylus doesn't. It's really funny this. If I pretend it's a real pen, it sometimes starts working again. Now it's lying to me and not working at all. That is disappointing. Maybe it's because it's got this extra stuff on top. Oh, let's see if it works if I use the extra stuff on top. I don't know. No, it doesn't like that either. Alright, we'll close it and open it. This will be the exciting part of the video for those watching on the video. I can feel the excitement already. Sometimes, yeah, look at that. It's working now. So delta is that triangle-shaped thing. That's a capital Greek D. And the Greek letter for D is delta. That's what they call it. A lowercase looks like that. It's like a D, but with a squiggly little thing like that. That's a lowercase delta. Capital Greek delta is used in a lot of places. It usually represents a change. So you'll see it a lot in chemistry for a change in concentration of something. Or a change. Yeah, you might have seen that. Or a change in speed. In physics as well. Yep, delta V over, or delta X over delta T, change in displacement over change in time, average velocity. Yeah. So you'll see that from time to time. I just wanted you to be aware of it. Good question. Yes, another question. Good question. We have to have some conventions in maths. Maths only works because everyone who uses maths agrees to follow the same rules. Sometimes we make up branches of maths where the rules work differently. But for the main part and for what you're going to do at school, we're going to work in the ones where we all agree to the same rules. We tend to read from left to right. So our gradients are described from left to right. So our run is always in a left to right direction. So then we can tell whether a rise is up or a rise is down. As long as we read left to right, that's why the negative one is downhill from left to right. No, they tend to still do it this way because the origins of this mathematics and the terms used to be described this way. But yeah, it's a good question because in some languages where they read right to left, we still tend to have this positive going uphill from left to right. But it also works because our quadrant in maths, you know, the positive x-axis is to the right and the positive y-axis is up. So it's a little bit easier for us. If your origin is reading right to left, it's a little bit more challenging to do it the other way. But as soon as you see, well, that's the direction in which the x and y values are increasing, we're fine. It could have, when they first decided to do this, someone could have decided, you know what, we're just going to deal with the positive direction being left and the positive direction being down. Someone could have done that. But it seems more intuitive for most of us that positive is to the right and positive is up. So that's the way we tend to do it now. Good questions, though. This little special thing here. Positive, negative, zero we've seen. We've seen vertical lines, and I didn't explicitly mention what the gradient of a vertical line is. It's an undefined gradient. What do we mean by undefined, and why does it look like that? If my x-coordinate is not changing, then the change in x is 0. So I'm dividing by 0. Have you ever tried dividing by 0 on your calculators? What happens? Doesn't give us 0. Have a try now. If you've got one on you, have a try. Do 7 divided by 0. See what it gives you. Like when you started thinking about division being how many times does that number go into the number you were dividing. So 7 divided by 0. How many zeros do I need to make the number 7? Is there any number of zeros that's going to get me to the number 7? Not really, is there? So division by 0 is undefined. We can't make meaning of it. Another interesting way to think about it is, as we're approaching 0 from the positive side, if I divide by a positive number, I'm approaching infinity, but infinity is not a number we can really get to. At least most of the time it's not. It's more just the concept. But if I was approaching from the negative side and I was dividing by negative values getting closer and closer to 0, I approach negative infinity. And that doesn't make a lot of sense. Like if I do 3 divided by 0, I could look at 3 divided by 0.1, 3 divided by 0.01, 3 divided by 0, 3 divided by negative 0.1, 3 divided by 0.01, 3 divided by negative 0.1. And some of these we can work out. When I divide by 1/10, that's the same as multiplying by 10. I get 30. This is going to be 300. But when I'm coming the other way, if I divide by negative 1/10, I've got negative 30. If I divide by 1/100th, I've got negative 300. If I was trying to sketch what's happening here, as I'm coming back towards 0, the graph starts zooming up positively. It starts increasing positively in the positive y direction as I get closer and closer to 0, as my x value gets smaller and smaller. But if I'm coming from the negative side and my x value is getting smaller and smaller, suddenly my y value, when I divide by x, is approaching negative infinity, way down there somewhere. We can't make sense of it because dividing by 0 doesn't make sense in maths. It's not an operation we can do, so we say division by 0 is undefined. And when you're asked in the exam, what's the gradient of a vertical line? You just say, undefined. 0 is totally wrong. 0 gradient is a horizontal line. It's not increasing or decreasing. A 0 gradient is exactly horizontal. A vertical line has an undefined gradient because I'm not actually changing my distance at all. I'm dividing by 0. Division by 0 is undefined. So that's what we've called it. We've called it undefined. Mathematicians have agreed vertical lines have an undefined gradient. Nothing else special about them. That's just the name for it. The reason why it's undefined is because we can't agree on what the value should be. It's not approaching it's not approaching the same value from the left and right. It doesn't look like we're getting to the same answer. We can't define it. There aren't many things you've seen in maths where we don't know how to do it. Division by 0 is one of those things. You can make up branches of maths where you can divide by 0, but we're not going to do that. What's one other thing that you know of that we can't do in maths? It's like one other thing you're probably familiar with. Might have talked about it already. You guys know how to find a square root of a number? Yeah? Square root of 2, we can't get a nice fraction for it, can we? That's true, but we can find a number for it. Square root of a negative number, that's a little bit different, isn't it? In our real number system, your calculator finds square roots of negatives? Oh, if you've got complex mode, of course it will. Yeah. So we've made up a branch of mathematics and a set of numbers where we've decided we can square root negative numbers. But in the main, in the real number system, we can't find the square root of a negative. Because if I square a negative number, it ends up being positive. If I square a positive number, it's positive. So we can't usually find the square roots of negatives. We can't divide by 0. They're two of the things that we're not really allowed to do in the real number system in maths. All you really need out of that, though, I think you already knew. Positive gradients going uphill left to right. Negative gradients going downhill. 0 gradient, my favorite way to walk. Flat, don't have to go up or down. Undefined vertical gradients. That might be the special new bit. Everything else in there is just a gradient calculation. It's nothing too exciting. Let's see if we can label these really quickly. For each graph, state whether the gradient is positive, negative, 0, or undefined. Is this going uphill or downhill, the first one? Downhill, so negative. Number B, uphill, number B, don't you like that? Uphill, downhill, 0, or undefined? 0. C, undefined. And positive. This was really not stretching your brains very much, was it? You guys did great. You listened to what I said, and now you can do all the questions. It's not very hard. Oh, how do I find the gradient between 2 points? We did this the other day, so this is going to be easy. y2 take y1 over x2 take x1. 2 over 1. M equals 2. You do the next one for me. I'll give you, 15 seconds. That's enough time. That's 3 times as long as it took me to do that one. Oh, that's so sweet holding hands. She is a good friend. B's the same. y2 take y1 over x2 take x1. Negative 3 take 1, negative 4. 2 minus negative 5. When you subtract a negative, that's adding, isn't it? 2 plus 5 is 7. x1, y1, x2, y2. Remember I said, hot tip, if you sometimes get them confused, make sure you label them first. Then you'll get the bits in the right place. It'll make your life easier. Good observation. Yes. Difference in y coordinates. y2 take y1 over the difference in the x coordinates. x2 take x1. So my second y coordinate was negative 3, and then I had to subtract 1. My second x coordinate was 2, and then I had to subtract negative 5. Why does subtracting a negative, does it make sense to us that when we subtract a negative, it ends up making addition? It does? Yeah, good. Oh, that's good. I don't need to explain why then. That's good. I have lots of interesting ways of thinking about that, but if you guys are all over it, I will save that for another day. Wow, that exercise is going to be really easy for you as well. So 4C and 4D, kindergarten maths for you guys. Isn't that nice? Maybe I'll throw a tricky question in there somewhere, but they're really not hard. Last little bit I'm looking at, so we're ticking off the exercises we left from last week. So this is 9D. Wow, arrays for 2-step experiments sounds confusing. Guess what an array is? Anyone in here do any programming? What's an array? Yeah, it stores a bunch of things. It's a type of variable, usually a table. So an array, when we're programming stuff, is just a table. We've got rows and columns. So when they're saying arrays, they're just saying using tables to help solve 2-step experiments. They're just probability questions. Oh, it's not so scary at all. Probability questions, sometimes it's convenient rather than using a Venn diagram to draw a table. We actually did this the other week as well, so it won't be very hard. Let's look at their example then, let's do our own. 2 coins are tossed. Draw a table to list the sample space. A reminder, the sample space is the list or set of all possible outcomes. So they've drawn a table. On the first coin, they've said toss 1. I'd probably write coin 1, but it doesn't really matter. And I'd write coin 2, you can label them different things. It still makes sense. Either I'm getting heads or tails on the first coin and heads or tails on the second coin. So the 4 possible outcomes are 1 head on each coin, the first coin being heads and the second one being tails, the first coin being tails and the second coin being heads, or tails and tails. So my sample space is the list of each of those 4 possible outcomes written as a set. Sets, remember, get the fancy little curly brackets, the braces. From that, can we answer their questions? What's the probability of obtaining heads and then tails? Oh, it moved my thing. There we go, that's better. 1 in 4, because of the 4 options, only one of them has heads on the first coin and tails on the second. The second question, they're asking almost the same thing, but they don't care which order you get it in. What's the probability I get exactly 1 head? Well, now there are 2 options, the second option and the third option, where I can obtain 1 head. So it's 2 out of 4. Are we okay, Bonnie? What's wrong? Yeah, please get your charger for your student loan laptop. Oh, what did you do to your computer? Yeah, that happens. What did you do to your computer, though? I blame your brother. It seems fair. All right, so we've got one for you guys to try. 2 identical counters have a red side and a blue side. They are each tossed. Draw a table to list the sample space. I'll draw the structure of the table just in case you're not really confident with that. I could have called it counter A. Why do I have to use numbers? I don't know either. That red's a little high, isn't it? So all you got to do is make a little table, fill in the blanks. Yeah, you're doing it. Oh, I'm giving you a chance. I don't want to have all the fun. I do want to have all the fun, but I want you to share in the fun. Please no self-harm in class. No hitting ourselves in the head with a book. It didn't hurt the book? How do you know? Fair enough then. I will trust your judgment. That's going to confuse everyone at home who watches this. Oh, it would help if I actually looked at my table, wouldn't it? Red, 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 blue, blue, red, blue, blue. Did we manage? So the sample space, if I wanted to write it as a set, I could get a red and a red. I could get a red then a blue. I could get a blue and a red. Or I could get a blue and a blue. Sample space, written as a list inside the fancy curly brackets. Okay. They're the possible outcomes from this experiment of rolling 2 identical counters with 1 red side and 1 blue side. Great. What's the probability of getting blue on each? What do we reckon? 1/4. Why is it 1/4? Yeah, it's the number of favorable outcomes There is a U in there somewhere. There was only one favourable outcome of blue and blue. The last one there, wasn't it? And it's divided by the total number of possible outcomes. What's the probability of having exactly one red side showing? So, that one there, and that one there really, aren't they? Are they the only two where there's one R? The last one doesn't have any R's. The first one has 2 R's. Too many. So the probability of one red side would equal 2 out of 4. You guys would simplify that down to 1/2 for me. If I threw in my own beautifully fun question, probability of at least one red. At least means one or more. Now I've got to include that one as well, don't I? The double R. And it would be 3 out of 4. Not surprisingly, you guys have astounded me with your amazingness. That's good. You are amazing. So, what were the exercises we did? I can't remember. It was C and D. Was it exercise 2? Let's go back and have a look. Maybe exercise 3. It was 4. Look at that. 4C, 4D, and the one we're currently on, 9D. You guys are welcome to work through a few exercises of that. If you're finding it easy, go to the problem solving and reasoning questions. You'll still find them fairly easy, but it'll be great. Yeah. Yeah, if you'd like to work outside, that is fine by me. Yes. It's optional, but I would do them all, because that's more what your questions you're going to have trouble with on my exams. It's almost like you don't want to have fun. You want to deprive yourself of fun.